Welcome to part 2 in my series, Introduction to Gabriel Music Notation. I am your host and the inventor of Gabriel Music Notation, William Tapley. In my last program, I discussed the advantages of Gabriel's new 4-line staff as compared to the 5-line staff of traditional music notation. And later on today, I will tell you how you can purchase my new book, All Keys Are Easy, Volume 1, which explains my new system in greater detail and gives many examples. Now, in this program, I will discuss the new 12-toned Gabriel chromatic scale as it registers on the new 4-lined staff. And as seen in the illustration at the bottom, the result is notable, pardon the pun, please, because it makes learning to read music 15 times easier than traditional notation, as seen on the top. However, my creative process in formulating Gabriel music notation did not begin by designing a new staff. It actually began by devising a new chromatic scale, and the structure of the staff as a vehicle for registering the new 12-tone scale fell into place later on. For hundreds of years, other innovators have known about the tremendous advantages that a 12-tone chromatic scale could provide in learning to read music, as opposed to the current 7-tone system. A chromatic scale simply consists of all 12 tones of a scale, as is expressed by both the black and white keys together on a keyboard. And each of those 12 tones are separated by a 1/2 step vertical interval. And the 15 most common keys use 7 of those 12 tones in various combinations. However, each proposed improvement over the years has been accompanied by corresponding drawbacks. You can find many of these proposals on the musicnotation.org website or in the book, Source Book of Proposed Notation Reforms, and I have a copy right here. Published in 1987 by Gardner-Reed, this 475-page book describes hundreds of innovative ways to improve upon Guido d'Arezzo's 1,000-year-old system. Unfortunately, every one of these proposed systems, except, of course, my own Gabriel design, adds more problems than they solve. The many drawbacks of those notation reforms are all solved by Gabriel notation, without losing any of their advantages. Incidentally, you can find my Gabriel notation on pages 109 and 267 of Gardner-Reed's book. Although I should add that Gardner-Reed did not understand nor accept my Gabriel solution. Now, the first problem with previous chromatic scale proposals is that their 12-note systems obviously require almost double the staff height of the 7-note system as printed in our current notation. Unfortunately, adding more lines to the traditional staff sharply reduces legibility, even when some of the lines are dotted or dashed or skipped entirely. The overall resulting staff is much less readable, as well as nearly double in page height. My eureka moment occurred when the insight came to me: instead of adding staff lines, why not compress the scale instead? That way, succeeding note heads can be separated by 1/3 note head intervals instead of 1/2 note head intervals as found in traditional notation. This new compressed arrangement allows 12 notes to register in the same staff height as 8 notes in the current system. In other words, only slightly more space than the current 7-note notation. And thus it solves the number one problem as found in all previous notation proposals. You don't need to add any dotted, dashed, or colored staff lines. This illustration shows how each staff line in the compressed Gabriel staff registers 4 note heads instead of 3 note heads. 2 notes are tangent to the top and bottom of a line, in this case E and G, while 2 more notes intersect the line at 1/3 and 2/3 note head intervals, in this case F natural and F sharp. The F natural is represented by white oval-shaped notes intersecting the line, and the F sharp is represented by a black diamond-shaped note intersecting the line. Incidentally, this staff segment could be from either the bass or treble clef, since all clefs in Gabriel are analogous, which is another very important advantage of Gabriel music notation. That's how I know what tone those note heads represent, even though there is no clef sign indicated. This new pattern works very well, even if all the note heads were white and oval-shaped, and thus not distinguished from black keys. However, further modification made my new chromatic scale even more readable. This modification came after close examination of keyboard design. Thus, I substituted black angular-shaped note heads to indicate the black keys on the keyboard, while the white oval-shaped note heads continued to indicate the white keys. Thus, all the various sharps and flats are instantly recognizable. So how did I choose this particular arrangement? I observed how the black and white keys on a keyboard are distinguished by more than just color. I think it will become obvious as we continue with this program that keyboard design itself is a marvelous accomplishment. Black and white keys are distinguished from each other not just by color, but also by size, shape, and position. Thus, I experimented with various black diamond-shaped note heads for sharps and flats to find out if applying the same keyboard design principles to notation could maximize Gabriel's readability. Looking at the chords in this illustration, notice that the black keys on the right are differentiated from the white keys by color, size, shape, and position, which follows the same design principles that we see in keyboard design. Notice how the chords in traditional notation at the left in this illustration look very regular, but looks can be deceiving. For example, the chords in both the bass and treble clef on the left look like they register the same notes, but only Gabriel notation on the right clearly shows that those same notes are not the same in both clefs. The next advantage is Gabriel clefs are analogous, as I said before, which means that the same notes register in the same locations in all clefs. Also, only Gabriel notation shows the correct interval spacing between major and minor thirds and other intervals. Traditional music notation cannot make that important distinction. The advantage of having black and white note heads match the color of their keys also means that Gabriel notation does not need to add clef signs in the key signature, as in traditional notation, in order to know which notes to play. Key signs in the clef are retained in Gabriel in order to know which octave to play. They are also retained for music theory, although they may well be removed at some time in the future, since they are not really needed for indicating which keys to play. I should point out that Gabriel notation is even more accurate than the keyboard itself in displaying the correct tonal relationships between notes. For example, on a keyboard, the distances between the white keys E and F and B and C, which are a half tone apart, are the same as the distances between the other white keys, which are whole tones apart. With Gabriel, all tonal intervals are rendered accurately. In the example shown, the chords appear very regular in traditional notation at the left, All the notes in these chords are located in either the lines or the spaces of the bass and treble clefs, and the note intervals look identical. But in fact, they are not identical. For example, the intervals for minor thirds and minor thirds look the same, but are not the same. Gabriel notation correctly shows the difference between major thirds and minor thirds, as shown in the chords on the right. And it also correctly shows that the notes are not the same in the same locations on the two clefs, as you might assume from the chords in traditional notation. And another advantage of Gabriel music notation over traditional notation is that the difference between sharps and flats, double sharps, double flats, etc., are all indicated by the note heads themselves, rather than by the key signatures. On keyboard instruments, it doesn't matter due to equal temperament, as you can see in the illustration, since the black keys sound both flats and sharps, as well as double sharps, double flats, etc. And sometimes even the white keys can sound, both double flats and double sharps. Notice in this illustration how much more accurate Gabriel notation is compared to traditional notation, which is all over the place. Just look at the first three notes: F, double flat, E flat, and D sharp. Both systems tell you to play the same black key. But Gabriel notation gives a much clearer visual message, and the same with all the other notes. For other instruments that can sound the difference, Gabriel notation uses similar but slightly different note heads for sharps and flats, as we can see in this close-up, looking at E flat and D sharp. The two note heads use the same shape, except flats are parallel to the staff, while sharps are at an angle to the staff lines. For double sharps and double flats, again, it doesn't matter in equal temperament. But for other instruments, a double flat is indicated by one white dot at its center, or two dots if it is a double sharp. Double sharps or double flats that are expressed by white keys on a keyboard are white and oval shaped in appearance, but also show one or two dots inserted to represent double sharps, two dots, and double flats, one dot. Double sharps and flats that fall on black keys use the same iconography, except they show white dots on black note heads. A good example of how these various note head expressions look in actual music can be seen in this excerpt from Chopin's Waltz in C sharp minor. Now, in conclusion, we have seen on this program how Gabriel applies the logic of keyboard design to notation design. You only need to learn one chromatic scale in order to play all music. Wouldn't it be absurd if we had to have 15 different pianos to play 15 different keys? It's time we had a notation system that is as easy to read as a keyboard. Now, on my next program, I will continue my exposition of Gabriel music notation by giving many more concrete examples of how the Gabriel chromatic scale intersects with the Gabriel staff in many different key signatures and in many different grade levels. If you would like to purchase my book, which explains Gabriel notation, and which is called All Keys Are Easy, Volume 2, go to my website, thirdeaglemedia.com, and look for the PayPal tab. And click on the $21 tab, or you can send a money order to me. Make sure the money order is for $21. William Tapley, Post Office Box 291, Osage, Iowa, 50461. Now, if you live in Canada, the cost is $36 because of the increased postal rates. And all prices include shipping and handling. And I hope to see you all again on my next program, which will be all about Gabriel music notation and its tremendous advantages over our current traditional system.